Today we're going to look at section 10.8, right triangle trigonometry, a very basic introduction to some concepts of trigonometry. Focus of this section is on right triangles. We'll look at how the Pythagorean theorem is used to find unknown sides of a right triangle, and we'll also study the special triangles, those with set ratios between the lengths of the sides. By ratios, we mean the relationship of one side to another side. When you think about ratios, you should think about fractions. Fraction is a ratio, the ratio of the numerator to the denominator. Finally, we'll preview trigonometry, learn about the basic trigonometric functions sine, cosine, and tangent, and how they are used to find not only unknown sines, but unknown angles as well, with little information. So, Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are two sides or legs of a right triangle, and c is the hypotenuse, as shown in the figure here. So use the Pythagorean theorem to find the missing side. So I know a squared plus b squared equals c squared. I don't know a, but I know b is 12. I know c is 13. Go ahead and square. I have 144, 169. Subtract 144. A squared is 25, so a equals 5. That's simple. The applications of the Pythagorean theorem are countless, but one especially useful application is that of distance. In fact, the distance formula stems directly from the theorem. How far is it to your workplace as the crow flies if the blocks in the figure measure 200 feet by 200 feet? So we simply take 200 squared plus 200 squared equals our distance squared. This is 40,000 plus 40,000 c squared. This is 80,000 equals c squared. And again, you should have a square root button on your calculator, in which case this is easy enough to do. And I get rounded to two decimal places, 282.84 feet. And that's c, not c squared. Okay. If 10 inches is the maximum possible vertical rise as shown in the figure, how long would the ramp have to be to pass the building code of 12 horizontal inches to 1 vertical inch? So same problem here. We have 10 squared plus 120 squared equals c squared. So 10 squared is 100. 120 squared is 1,400 or 14,400. So I have 14,500 equals c squared. Take the square root, 14,500, and I get 120.42 inches. Pretty much not a whole lot of change between the length and the angle. So next we look at a specific triangle called a 30, 60, 90 triangle. In geometry, as in all fields of mathematics, there are always special rules for special circumstances. There are special formulas and procedures to apply to certain types of problems. What is needed is to remember the formula and remember the kind of problems that fit. Sometimes we believe that because a formula is labeled special, we will rarely have to use it. That assumption, of course, is incorrect. So we have a 30-degree, 60-degree, 90-degree triangle, and why is it special? Well, because the side opposite the 30-degree angle in relation to the hypotenuse, the hypotenuse is twice the shorter leg, and the longer leg is the shorter leg times the square root of 3. Always with a right triangle with 30, 60, 90-degree angles. So can we find the lengths of our missing sides? Okay, so we have the length of the shorter leg. So the hypotenuse is simply 2 times 15 or 30. And then this is simply the square root of 3 times 15. And if we want to go ahead and calculate that, we get 15 times the square root of 3. And we get approximately 25.98 equals B. You want to repair a window on the second floor of your home. If you place the ladder at a 30-degree angle to the ground, the ladder just about reaches the window. How far from the wall should you place the ladder? And how far up will the ladder reach? So I have my hypotenuse, which is 24. B is the shorter leg, so it is 1/2 of that, or 12. So B equals 1/2 of 24, 12 feet. Now A is the longer leg, so it's square root of 3 times B, which is 12 times the square root of 3 times the root of 3, roughly 20.78 feet. Okay. Next, we have the 45, 45, 90 triangle, which is another special triangle such that with the measure of one side, we can find the measure of all sides. The two angles adjacent to the 90-degree angle are equal and each measure 45 degrees. If two angles are equal, so are their opposite sides. So, essentially what we're saying is the measure of the leg is x and the measure of the hypotenuse is x times the square root of 2. So, find the measure of the unknown side. Well, we know that x times the square root of 2 equals 8. So x equals 8 divided by the square root of 2. So we have 8 divided by square root of 2, and we get x is approximately 5.66. Okay, so that brings us to trigonometry functions. Trigonometry developed around 200 BC from a need to determine distances and to calculate measures of angles in the fields of astronomy and surveying. It's about relationships or ratios of angle measurements to side lengths in primarily right triangles. However, trigonometry is useful in calculating missing side lengths and angles in other triangles and many applications. So, we're going to need a scientific calculator, and it must have the capability to calculate trigonometric functions. So, trigonometry is based on 3 functions: sine, cosine, and tangent. These are what your buttons should be labeled. Letting the radius equal the square root of x squared plus y squared, which is the hypotenuse of a right triangle, we have the table below. The functions are given in terms of x, y, and r, and in terms of sides relative to the angle, like opposite, adjacent, and hypotenuse. So the sine of some angle theta is equal to y over r, which is the opposite side over the hypotenuse. Don't know what happened here. The cosine is x over r, or the adjacent side over the hypotenuse. And the tangent of theta is y over x, which is the opposite over the adjacent. Okay, so we'll be applying the sine function, cosine function, and tangent functions to find side lengths and angle measurements for triangles. We cannot solve using any technique we've studied so far. I have an illustration mainly to identify r and the sides labeled x, y. An angle theta sweeps out in a counterclockwise direction from the positive x-axis and stops when the angle reaches the desired measurement. That ray extending from the origin that marks theta degrees is called the terminal side because that is where the angle terminates. Regardless of the information given in the triangle, we can find all missing sides and angles using trigonometric functions. So this y is the opposite side, x is the adjacent side. So let's use the trigonometric functions to find the sides x and y as long as your calculator mode is set to degrees. You do not have to enter a degree symbol. So we have sine theta equals y over r and theta equals 60. R is 2. So y equals 2 times the sine of 60. And let's see what happens here. I hit 2 times sine 60. And I believe my calculator is not in degrees. Okay, so now that I have it in the right mode, we hit 2 times the sine of 60 and we get 1.732, and I'll stop there. So now to find x, same thing. X is equal to 2 times the cosine of 60. So 2 times cosine 60. And that is 1. Now we have all sides. This is probably the square root of 3. Let's double check that. Square root of 3. Yep. So now we have all sides. 1, square root of 3, and 2. You can also check it using the 30-60-90 ratio. So we have common angles, which should find helpful. Find the length of the missing side in the given figure. So what do we know? We don't know R. So I need a formula, and I don't have a standard 30-60-90 or 45-45-90. So I need something that's x and y, which I believe was the tangent. So let's go back to our table. Yep, y over x. So the tangent of 40 equals y over 5. So y equals 5 times the tangent of 40. Now, when we key this in the calculator, you don't have to hit degrees. You're in degree mode, so your calculator should know. So 5 times tangent 40 And I get 4.195. 4.195. So now, which of our formulas, this is our adjacent, and we want to find R. Now, which formula had the adjacent and R in it? And go back and look. Cosine. So cosine of 40 degrees equals R over 5. Was that correct? Let me double check that. No, X over R. So R is on the bottom. So this would be 5 over R. So now R times the cosine of 40 with a 5. So R equals 5 divided by the cosine of 40. Key that in. 5 divided by cosine 40. And I should get 6.527. There we go. Okay. Find the missing side at angles in the figure. Okay, opposite over hypotenuse. Opposite over hypotenuse. I'm getting old. Opposite over hypotenuse. That is sine. So we're looking at alpha here. So the sine of alpha, alpha, is equal to 6 over 8.3. Doo-doo-doo-doo. So you should have a button also, or typically above, like that. So if I take 6 divided by 8.3, I get the sine of alpha equals 0.72289. Then I could hit this button, which is called the inverse sine of 0.72289, and I get 46.3 degrees, which tells me that beta equal to 180 minus 46.3 minus 90, which is 43.7 degrees. So now I have my angles and I need to find x. And we can do trigonometry or we can use Pythagorean theorem. X squared plus 6 squared equals 8.3 squared. X squared plus 36 equals 8.3 squared, which is 68.89. X squared equals 32.89. So x equals the root 32.89, 5.73. And there we have it. Okay. Small plane takes off from an airport at an angle of 31.3 degrees to the ground. About two-thirds of a mile, 3,250 feet from the airport is an 1,100-foot peak in the flight path of the plane. The plane continues that angle of ascent. Find the altitude when it is above the peak. And how far will it be above the peak? So we need to know how high it is after. So here I have y. Now, again, double check these formulas. I'm looking at tangent, opposite over adjacent. So technically, this is x and this is y, and the tangent of theta equals opposite over adjacent, y over r, or y over x. So I know I have the tangent of 31.3 degrees equals y over 3,520. Multiply, and I have 3,520 times the tangent of 31.3 equals y. So 3,520 times tangent 31.3 gives me 2,140, and we'll round down, feet. So that's the height. How far will it be above our 1,100 feet? About 1,040 feet above. Okay. You know the lengths of two sides in the right angle as shown in the figure. Find the length of the third side and the other angles. Well, again, a squared plus b squared equals c squared. 7 squared plus 4 squared equals c squared. 49 plus 16 equals c squared. C squared equals 65. C equals, where is 65, which is roughly 8.06. Okay, we can work on tangents here. That way we don't have to use our estimated, our rounded figure. Tangent is opposite over adjacent. So looking at this angle here, opposite is 7, adjacent is 4. So the tangent of theta equals 1.75. So again, we should have a inverse tangent button of 1.75. And we get approximately 60.26 degrees. So if this is 60.26 degrees, and this one's 90, of course, this would be 29.74 degrees. So next thing we look at is called an angle of elevation and an angle of depression. Other problems that involve trigonometric functions include calculating the angle of elevation and the angle of depression. These are very common applications in everyday life. The angle of elevation is the angle formed by a horizontal line and the line of sight from an observer to some object at a higher level. The angle of depression is the angle formed by a horizontal line and the line of sight from an observer to an object at the lower level. Travel to Chicago. Visit the observation deck at Willis Tower, 1,450 feet above the ground. You can see the magnificent mile to the northeast, 6,864 feet away. What is the angle of depression from the observation deck? Okay, our problem here is this is what we can do. Tangent of our angle is equal to 6864 over 1450. Right? Opposite over adjacent. 6864 divided by 1450. Now the tangent of our angle here is 4.73, and we'll go 38. So taking the inverse tangent, uh, 4.7338, what do we get? Inverse tangent 4.7338. I get 78 degrees roughly. So if this is 78 degrees, that makes this 12 degrees. Okay. All right. You're flying a kite on a 60-foot string. The angle of elevation from the ground to the kite is 50. How high above the ground is the kite? So we're looking at opposite over hypotenuse. And again, might be handy to have this little table here for yourself. We're talking opposite over hypotenuse, so we're looking at sine. So the sine of 50 equals the opposite, which is our unknown, over the hypotenuse 60. Now 60 times the sine of 50 degrees is x. So 60 times sine of 50 equals 45.96 feet. We'll call it 46 feet. And that is the end of our trigonometry section.